All right, so we're going to take a look at the second half of section 7.2. Again, if you're a little fuzzy on the first part, that's why I kind of went over it, but you don't really need to know it in detail to do this part at all. All right, so the goal, at least for the first part of the section, we're going to try to take something that's written as trig and convert it to just algebra. Okay, how do you know something is a trig expression? What does it have to have in it to be trig? For example, this is not a trig equation at all. That's just algebraic. So what does it have to have in it to make it trig?
It has to have a trig function.
Yeah, it's got to have a trig function, like a sine, cosine, tangent, or inverse sine, inverse cosine, something like that. Right, so we're going to look at problems like this. Okay, I'll do this one in a little bit. This is all trig, okay, taking the sine of the inverse cosine, but we're going to convert that into an algebraic formula. So there's no sine or cosine in it at all. Just maybe some square roots and squaring things and some fractions, but no trig at all. Okay, just algebra. Right, so when you do this, you have what I call kind of like an inside function, and then you have an outside function. Okay, just to go back to it for a second, this is what I would consider the inside. That is the outside. Okay, the inside is the one in the parentheses. Okay, so what you're going to do is start with that inside one. Forget what's on the outside for now. Okay, we'll come back to it. But you're going to start with the inside function. And we're going to kind of draw a diagram of that inside function. So we're basically going to convert that inside function into a picture. Okay, because in math, a lot of times you can write things as an equation, or you can do it as a picture. Okay, for like especially word problems, things like that. So we're gonna change this inner function into a picture. And that's going to be the first step. And in order to do that, we're going to keep this in mind. If the inner function has inverse trig, okay, like the one I'm going to give you here, the inside function is an inverse trig function. It's going to help to take that and rewrite it, okay, when we make our picture. Okay, we're going to rewrite that inside function using regular trig, okay, instead of inverse trig. It might sound a little confusing, but it's not too bad. Okay, and as we go through this, we're going to be drawing right triangle diagrams. So keep in mind the theorems you're allowed to use with right triangles. Pythagorean Theorem. Okay, leg squared plus leg squared equals hypotenuse squared. Okay, that's going to pop up quite a bit. And there are certain restrictions with inverse trig, especially on the angles. Okay, so if we're going to be dealing with right triangles, you're never going to have an angle bigger than 90. Okay, so keep that in mind. When you're sketching your triangles, you should never have an angle bigger than 90. And you should never have a negative angle either. If you get a negative angle, something's not right. And as far as the notes, that's all I can really explain to you without just doing a problem. Okay, we just have to try it and see how to set it up. Okay, any questions on what the goal is? We're going to take something that has trig, and we're going to get rid of all the trig. Okay, that's the goal. And you can't do this with just any problem. The problems I've picked are going to work out. They're going to work out nice. Okay.
So Hager, does it have something to do with like when you try to find the sin of like an angle that is like across, and then you use hypotenuse and stuff?
Yep, we are going to need to know the SOHCAHTOA stuff. Yep, opposite over hypotenuse, adjacent over hypotenuse. Yep, that's going to come into play when we look at the outside function. All right, so here's our first example. It says, write an algebraic expression in terms of v. So right now, I could give you a number for v, like 0.3. Okay, and let me just plug it in. Let's take the sine of the inverse cosine of 0.3. Okay, and I get that number, 0.9539. Okay, so keep that in mind. When I'm done, I want another way to get 0.9539, but I don't want to press any trig buttons on the calculator to do it. Just algebra. So algebra, you can add, subtract, multiply, divide. You can square things, square root things, fractions. Okay, but you can't press sine, cosine, tangent. You can't press any of those. Right, so we'll come back to that. And why did I pick 0.3? I could pick anything that works. I just picked 0.3 just as a number to try. So the directions say, first thing you're going to do is start with the inner trig function. And if the inner trig function contains inverse trig, we're going to rewrite that. All right, so let's forget about the outside for now. Okay, I'm starting with that inner function. Okay. I asked this earlier, but anytime you do inverse trig and then you hit enter on the calculator, what kind of answer do you get? Inverse trig always gives you what kind of answer? Denver? I'm thinking of a type of thing. It's like a name. No, it could give you a decimal. It could give you a fraction. Could give you an integer. It depends on the problem. But I'm thinking of what it represents. It's something geometric.
Oh, really?
It could be. That's how you can write the thing I'm thinking of. What do you use radians for? Angles. Okay? So anytime you do inverse trig, it's going to be equal to an angle. In this problem, I don't know what the angle is, so let's just call it theta. Theta is used to just represent a generic angle in trig. All right, now it says take the inverse trig and rewrite it using regular trig. So I want to get rid of inverse trig. How do you cancel out inverse cosine? Cosine. And this is something we did in the first part of the section. Take the cosine of each side. What you just did is you did cosine, inverse cosine. You canceled them out. What's on the left-hand side now? Okay, so that's on the right. And what about on the left? V. Okay. So now it says the cosine of some angle equals V. Now I'm going to draw a picture of that. And this is where opposite, adjacent, and hypotenuse is going to come in. Put theta wherever you want. Put it at the top, put it at the bottom. It doesn't matter. Okay, it doesn't make a difference. I'm going to put it right here. Now, I want this picture to represent that equation. I want the cosine of this to equal V. So first of all, I'm dealing with cosine. So what two sides should I be thinking about here?
Adjacent and hypotenuse.
Yep, cosine is adjacent divided by hypotenuse. So in this diagram, I need you to label the adjacent side, and I need you to label the hypotenuse. You can use anything you want, as long as when you divide them, the answer comes out to V. And there's an infinite number of ways to do it, but there is a simplest way. Can anybody think, what can you label the adjacent side as? And then what can you label the hypotenuse as? So if you divide those two things, the answer comes out to V. Denver? Okay, and which side do you want to make V? Adjacent or hypotenuse? Yep. Make the adjacent side V, and you want to make the hypotenuse 1. So now what you've just done, this picture, is this. You just drew a picture of what I put that box around. Now, I want the sine of that picture. Now, what is sine? Sine's not adjacent over hypotenuse. What's sine? Opposite over hypotenuse. The only thing is, do I know the opposite side right now? No, but it's a right triangle, and I know two of the sides, so how can I get the third side? I can do the Pythagorean Theorem, and I can find this third side. It's not going to be a number. It's going to be something with a v in it. All right, so for now, let's just, you can call it anything you want. We'll just call it x. We're going to know what it is in a second, so I'll cross that x out. And the Pythagorean Theorem says leg squared plus leg squared equals hypotenuse squared. Now the goal is to get x by itself. Okay, I want to know what x is. Okay, so how would I move v squared to the other side? Yep, minus it. So x squared, what's 1 squared?
1.
Is 1. Now I almost have a formula for x. Not quite. What do I have to do on each side? Square root. So x is the square root of 1 minus v squared. This kind of thing is going to happen in every problem. You're going to end up with an expression like that. Don't try to simplify it. You can't. That's as good as it gets. Okay, so this side is not x. It's square root 1 minus v squared. Now we know opposite. We know adjacent. And we know hypotenuse. Okay, we know every side. So now I can find whatever you want me to find. The sine, the tangent, okay, whatever. Okay, in this problem, they want the sine. So, can somebody remind me, when you find sine, what goes on top?
Opposite.
Opposite. Square root of 1 minus v squared. Divided by what goes on the bottom? 1, which is hypotenuse. So in this case, you really don't even need the 1. So the final answer is square root 1 minus v squared. So if you want to know the sine of the inverse cosine of v, all you have to do is plug it into that formula. This and this are exactly the same thing. I'll prove it to you. I'll plug in 0.3 for v, and I'll get 0.953939. Okay, so let's try it. You don't have to use 0.3. You can use whatever you want. Okay, but I used 0.3. So take the square root of 1 minus 0.3 squared. And when I hit enter, I get exactly the same thing I got before. So what we just did is we converted a formula that had trig into a purely algebraic formula. It's got square roots and subtraction, stuff like that. Okay, any questions on that problem? We're going to try the same process again. Got any questions on that? Okay, so that's it. It's basically the first part of this section. All right, so let's try this one. This time we've got tangent. It's a regular trig function. We got an inverse on the inside. We had sine. We had an inverse on the inside. It's going to follow all the same steps. All right, so let me, as I go through it this time, let me ask a few more questions rather than just going through it myself. What do I start with here? The outside function or the inside function? Yep, start with the inside function. And by the way, this doesn't have to be a v. It could be a q. It could be any letter. Okay, but I just used v. And anytime you do inverse trig, what kind of answer do you always get? You're always going to get an angle. So let's just put it equal to some angle. We don't know what it is. But now we want to draw a picture of that. So in order to do that, I want to get rid of something in that equation. Okay, what do I want to get rid of here? Inverse sine. Yep, I want to get rid of the inverse sine. And how do you get rid of inverse sine, Fred? Yeah, take the sine of each side. I mean, after a while, you could almost kind of skip this step and jump to what we're about to write, but if you want to go through it every time, that's okay too. Okay, so what am I, Nick, what am I left with for my equation there?
Equals sine angle.
Yep, phi equals the sine of some angle. Again, we're calling it theta. And now I want to take this equation and turn it into what? I want to turn that into a right triangle picture. Okay, where should I put theta? Doesn't matter. Let's put it at the top of this thing. Okay. Now, you have to label two of the sides and look at the function we're working with, sine. Okay. What are the two sides we're going to be dealing with? Opposite and hypotenuse. Okay, and you can label those two sides any way you want, as long as when you do this divided by this, you get that. Because the sine of this angle, opposite over hypotenuse, has to equal v. So, what could I label the opposite side as? Yep, you can use v. I think that's the easiest way to do it. So now opposite is v. And what do you have to put in the bottom to make the answer come out to that? You need a 1 for the hypotenuse. Okay, so we've got the opposite, we've got the hypotenuse. Now, if we go back at the original problem, what's the function on the outside? Tangent. What's tangent? Opposite over a side we haven't used yet. We don't know adjacent. How can I figure out adjacent? Yeah. I know two of the sides. Use the Pythagorean Theorem to find the third side. And then we'll be good. Okay, so for now, we can call the adjacent side x. We'll cross that out, though, because we're going to know it in a second. And can somebody set up my Pythagorean theorem using the x, the v, and the 1? Luke?
X equals v squared plus 1. Or x squared equals v squared plus 1.
So you put x squared by itself. Is that the hypotenuse?
Oh, no, that's the leg.
Yeah. So you can start with x squared, but
X squared and v squared
x squared plus v squared.
equals or 1 squared.
Yeah, 1 squared, which I'm just going to write as 1. Now we're going to get x by itself, just like we did before. X squared is 1 minus v squared. You might notice almost the same kind of thing happening here. So what's x? Square root of 1 minus v squared. You're going to see that happen all the time. The square root of 1 minus your letter squared. So put that in for x. Okay. Now you know opposite, you know adjacent, you know hypotenuse. You can find anything they want you to find, including the tangent. Okay. So tangent is opposite over adjacent. Okay. So let's write our answer. What's the opposite side here? V? Opposite over, what's the adjacent? Square root of 1 minus v squared. And at this point, you might see the answer left like that. Or what might somebody say is not quite simplified with that? What about the square root? It's in the bottom. Okay, so anytime you have a square root in the bottom, you can move it to the top by doing what?
Multiplying it by the square root.
Yeah, multiply by whatever's there. Doesn't matter, whatever it is. Multiply the top and the bottom by that. Okay, whatever squiggle happens to be. Okay. And then your final answer is 2 square root squiggle over squiggle. Okay, just fill in squiggle. Okay, so in this case, I have a 2 in place of the v, and in place of squiggle, I have 1 minus v squared. Okay, so I can write v square root 1 minus v squared over 1 minus v squared. In this case, squiggle is 1 minus v squared. Yes. Okay, so any questions, especially just how we at least got to this step? Okay, you might, if they don't ask you in the book, you don't have to simplify it to this step that's circled. If you get a multiple choice question and you get this as an answer and you don't see it listed, look for what I circled. They're the same thing. Yes, Denver?
That's just like the final answer. It's basically asking for the tangent. That's like the final answer.
Yeah, that's the final answer. Yep. So like if you plugged in, I don't know, 0.8 for v, and you plugged it in here, and you plugged it in here, you should get exactly the same thing. Okay. Another way you can check your answer is you could graph it. Graph the original problem. Let's see what happens. Tangent of inverse sine of x. Okay. Now graph what you think is the final answer. So we have x second, let's put square root, second square root, there we go. 1 minus x squared. It's just a little tricky to type in. So then you have to get outside the root and divide by 1 minus x squared. So if I did this correct and I typed it incorrect, when I graph y1 and y2, how should they look? They should be the same thing. Okay, so there's y1. I don't know if you could tell, but y2 just traced right over it. You could also go in your table and you could try values. Okay, they should come out exactly the same every time. If they do, then you found the right formula. Okay, so it's easy to check your answer. Okay, so any questions on that one? Okay, what's a little different about this one? Actually, a couple things different. Okay, this time they're giving you the inverse on the outside. And what else? Yeah, they gave me a number. They didn't give me a variable. So when they write evaluate, when you're done, they want the answer to be a number. Okay, so let's evaluate it. If they ask you to do it without a calculator, then this number right here has to be something nice. It's got to be a multiple of 30 or 45. I would not ask you to evaluate without a calculator if this wasn't 30 or 45, a multiple. All right, so just like last time, even though the inverse isn't on the inside, that's what I'm going to start with. I want to figure out the tangent of 3 pi over 4. That's what I want to know first. And then if I can figure out this, well, then I'll work my way to figuring out the inverse sine. Okay, if 3 pi over 4 is confusing because it's in radians, what might you want to do with 3 pi over 4? You can convert it to degrees if you need to. So that's the tangent of, well, pi over 4 is 45. This is triple 45. So how much is triple 45?
What was the question?
135. Thank you. If you don't want to convert to degrees, you don't have to. That's just if you don't like radians, you can convert to degrees and do the problem this way. Is this number a multiple of 30 or a multiple of 45? It's a multiple of 45. So what I'm going to do to draw it out is I'm going to draw it. Okay, I'm going to make a picture. And I'm going to draw a 45, 45, 90 triangle. Why? Because that number is a multiple of 45. Okay, I'm going to make my unit circle. And that's basically what I'm doing right now is unit circle trig. Something we did back in chapter 6.
If it's a 30, do you draw 30, 60, 90?
Yes. Yep. We just have to figure out what quadrant we need to put it in. So here's 0, 90, 180, and 270. Where's 135 degrees? Which quadrant? 2? Closer to 90, closer to 180, or right in the middle?
In the middle.
Right in the middle. Yeah, it's a 45-degree angle. Right here. Okay, so there's my 45, 45, 90. Now I just need the length of each side. Okay, and you can draw the 45, 45, 90 as big or as small as you want. Okay, because remember, we studied the idea that you can have similar triangles, and whether you find trig functions of that triangle, or that triangle, it's all the same. Okay? Different sized triangles don't matter. But I will give you a hint. The easiest triangle to work with here is making the hypotenuse a 1. If you don't want to make it a 1, you can make it something else, but 1 is the easiest number to work with. Does anybody remember how long each side is in the 45, 45, 90? If the hypotenuse is a 1.
Isn't it like 3 pi divided by 2 or something like that? Or is that radians?
So here we're looking for side lengths. So we're not thinking radians or degrees. We're thinking of how long something is. Yeah. Anybody remember those? Well, here's a hint. This is the 30, 60, 90, not the problem we're doing, but for the 30, 60, 90, those are your sides. Do those sides look familiar?
Aren't those like Pythagorean triples, right?
If they were integers, they would be. This is not a Pythagorean triple.
Oh, okay.
Pythagorean triples have to be like 3, 4, 5. Those are nice numbers. So here's your 30, 60, 90. Now, does that give anyone a hint what the 45, 45, 90 is? These two sides are the same. Yeah, it has to do with square root of...
Square root of 2 over 2.
It is, square root 2 over 2. Okay, so if you don't remember those two triangles, I would just write them down again. Okay, and now tangent is opposite over adjacent. This is your reference angle right here. Reference angle is always the angle tucked in right between the hypotenuse and the x-axis. Okay, no matter where you draw your triangle, it's always the one that's right near the origin. Okay, so now let's figure this out. Tangent is opposite over adjacent. John, what side is opposite that angle?
Well, it's the one closest to the 180. Like,
Well, how long is it? Because now we have everything labeled.
it's square root of 2 over 2.
Yep, square root 2 over 2. And now tangent is opposite divided by adjacent. How long is the adjacent side here? What is it, John?
Square root of 2 over 2.
Square root of 2 over 2. And what do we have to be careful about? Because of where the triangle is. It's going to be negative. Okay? If you know all this in your head, you don't need to make this picture. But I'm guessing that some people might have not remembered that, and they might have forgotten that this is negative, because 135 is in the second quadrant. So what do you get when you divide these two things?
-1.
-1. Okay. So now we just figured out the tangent of 135. That's going to get rid of that whole thing. Okay. Now we're asking this question. The tangent of 3 pi over 4 is -1. Okay, so we just simplified that. Now I want to know the inverse sine of -1. Okay, so any questions on how I at least got to that step? How I figured out the tangent is -1. Okay, if you don't remember, go back and look. I think it's section 6.2, unit circle trig. That's what we just did. All right, so inverse sine of -1. Let's see. This is what I want to know. What is my answer going to be? What kind of thing? Because I'm doing inverse trig now. Oh, Ethan? Well, what did we say? Or we've done it a couple times now. Whenever you do inverse trig, your answer is always... Sure. Can you help him out, Alex? Why would you use inverse trig? Anytime you want to know what? Luke?
Isn't it like the side of the triangle?
Nope, that's Pythagorean Theorem.
Oh,
Sides is the Pythagorean Theorem.
the angles of the triangle.
Angles, yes. Okay, so this is going to give us some angle. This is what I want to know. This is the answer to the whole problem. What is the inverse sine of -1? Okay, so the way I'm going to think about it is like this. Okay, if inverse sine kind of confuses you, well, think of it like this. That's exactly the same thing. All I did was take the sine of each side. Okay, so I'm just rewriting this in terms of that. If you don't like inverse sine, well, get rid of it. Turn it into sine and think of it that way. So this is asking, where does the graph of sine hit -1? Okay, so now we have to picture the graph of sine in our head, okay, which looks like that. And we're trying to figure out where that graph hits -1. Now, -1 is going to be an easy number to work with. If this came out to like 0.7, where does the sine hit 0.7, you couldn't do this in your head. Okay, but I made it so it came out to a nice number.
The maximum of all sine graphs, 1 and -1. So
The maximum is 1 and the minimum is -1. Yeah. So now I just want to know, what is this angle? Right there. That's the answer to the whole problem. Anybody remember what angle we hit -1 at? This is 0. This is pi over 2. We're looking for -1. 3 pi over 2. And that's the answer. Okay, so it's kind of two problems in one. First thing you had to do was unit circle trig to figure out the tangent of 3 pi over 4. And then, once you know that number, you're taking the inverse sine of it. Okay? And this would have had to come out to either a 0, a 1, or a -1 to do it in your head. If it doesn't, you can't. Okay? Okay, so let's check our answer and see if we get 3 pi over 2 radians, or that's 270 degrees. Okay, let me type it in. So let me type in inverse sine. Second, inverse sine of tangent of 135. Since I'm in degrees here, I'm going to use degrees from here. Okay, and we should get 270 if we did everything right, which is the same as -90. So, yeah. Okay, this problem did not say to give me an answer between certain values, so I would accept 270. Okay. If it said, give an answer that's negative, does anybody remember, what do you add or subtract to an angle to Okay, you can always do this and it doesn't change the answer. You can always add or subtract 360 as many times as you want to get different answers. Okay? That's how they got negative 90. Or that's why I got negative 90. Okay? But for this problem, I would accept that. That's fine. Okay? And what's the next answer going to be? How would you get the next one after 270? Yeah, add 360. And the next one after that? Add 360. Remember, this wave is going to keep repeating. So it's going to keep hitting -1 infinite times. Usually we just give one answer then, and that's good enough. All right. Let's try this one. This one is more like the first type you did. Inverse is on the inside. Regular trig is on the outside. Except this time you don't have a letter here. You have an actual number. So you're going to do exactly the same thing you did in 1A and 1B. But you're not going to have a letter. You're going to have an actual number you can type in. So we're not going to have to worry about variables. Right. So anyone think they can tell me how I should start this one off? What's always the first thing you focus on? Inside. Whether the inside is inverse trig, whether the inside is regular trig. Always start with the inside. If the inside is regular trig, like this one, then most of the time you're going to use your unit circle to figure out what is that number. Okay? And it'll always come out to something nice. If the inside is inverse trig, you're going to draw a diagram. Okay? You're going to draw a right triangle. All right, so Ethan, anytime we use inverse trig, what kind of answer do we get here? Same question I asked you last time, or someone told us. An angle. Okay, anytime you use inverse trig, we're solving for an angle. Now, if you want to draw a picture of it, there's usually something here we want to get rid of. Okay. What do I want to get rid of in that equation? The inverse, and how do I do it? Careful, you can only multiply by numbers. You can't multiply by words. Use tangent, and the word would be take. So take the tangent of what's on the left. Take the tangent of what's on the right. That and that cancel. So Ian, what's my equation now? Tan of the angle, yep. Okay, now draw a picture so that the tangent of that angle comes out to 1/2. Before you had to draw a picture so that the tangent came out to like V. Well, now you got actual numbers. So this should be hopefully a little easier. Okay, I'm dealing with tangent. Okay, what two sides, Austin, am I going to label? I need to label opposite and adjacent. Label them any way you want. Doesn't matter how big or small you make this triangle. I just need that to come out to that. So what should I label the opposite side? One, yeah, make the opposite side 1. What about the adjacent side? 2. Now you just drew a triangle where the tangent is opposite over adjacent, 1/2. And now we can get the hypotenuse by doing what? Pythagorean Theorem. And this is going to be the square root of 5. Yes. So now we've got all numbers. So now you can find the sine, the cosine, the tangent. You can find anything they want you to know. This time, they want the cosine of the picture you just drew. That box is the picture. So take the cosine of your picture. Brad, can you tell me the cosine here? So think, what's the first thing you need to know here?
What?
Yeah, you have to know the definition of cosine. Okay. So what's do you know our definition for cosine?
Adjacent over hypotenuse.
Yep, adjacent over hypotenuse. What's the adjacent?
That'd be 2 over square root.
That's it. That's the answer. 2 over square root 5. Or if they fix it so the root's not in the bottom, 2 square root squiggle over squiggle. Replace squiggles with 5s. Okay. And I'm not going to check it, but if you type this in on your calculator, you will get exactly the same thing. Okay. Any questions on that one? Okay, so this one's just like example 1A and 1B. It's all numbers though, no letters. Example 2A, that one's a little different than everything else. Okay, a little different. This is the one that was like, actually this one's just like the last one. Does anybody need to see another one of those?
That's a question on the last one. How did you get to be adjacent?
2, because of this 2 right here.
Okay, so it's literally like the opposite of adjacent?
Yeah,
Right.
this 2 came all the way back from the original, that was given in the original problem.
Right.
Yep. So if they give you a fraction in the original problem and it's tangent, the top is opposite, the bottom is adjacent. If they give you sine in the original problem, the top would be opposite and the bottom would be hypotenuse. If they give you cosine, then the top would be adjacent and the bottom would be hypotenuse. But they're always going to give you one of those 3. You're never going to have inverse secant or anything like that. It's always going to be one of those 3. Okay, so any questions, or does anyone need me to go through any part of the setup for this one? It's exactly like the last one, except this is going to be opposite and that is going to be hypotenuse. How do I know that? Sine. Okay, after you go through all the steps, that's what's going to happen. So any questions on that? What side would you need to find, because in the end they want to know this? Adjacent. So once you get used to this, this is how I would do the problem. I put theta here. I would just say, okay, opposite is 1, hypotenuse is 2. Use Pythagorean Theorem to find that, and then I'm done. I go right to the picture. But if you want to do those 2 steps before the picture, you can. And the side would be square root of 3.
Yeah, so you just say that like square root of 1 is 1, so I have to find out what the square root of 2 is, right? So I get to find out what plus 1 equals the square root equals 2 squared, which is 4, right? So
Oh, how I got this number?
yeah.
Yeah, you can think about that any way you want. Some people like to do the whole Pythagorean theorem out. Some people just kind of do it in their head. But yeah, however you do it. That would be the final answer to the problem. Okay? If you want to try it, you can check it later. But that's what you should get. All right, so keep in mind that when you're solving a trig equation like this, there's infinitely many answers. Okay? Think Think about where that line hits the curve. Okay? Hits it infinitely many times. So remember how you write that. You put plus period times n. Sometimes the period is 2 pi. Sometimes the period is pi. It could be something else. Okay, but when we graphed trig functions, we talked about periods. Okay, if they give you a problem that involves secant, cosecant, or cotangent, do you have a button for those on the calculator? No. So if you want to type in secant, cosecant, or cotangent, you might have to type it in, or you will have to type it in, as 1 divided by. Okay, so if you want to solve a problem with cotangent, you need 1 divided by tangent.
What about for inverse trig functions? How do you type that in?
I don't think we have any that we're going to do with typing in inverse trig.
Oh, so that's not going to be on the test?
No, not with this. No. To do that, it does have to do with flipping something, but it's not quite the same flipping as this. It's very easy, but it's just not something I want to explain right now. If you really want to know, I'll tell you.
Don't worry about it.
Okay.
Have things that are free.
All right, so let's try a problem. All right, so this one is asking us to find all solutions. Okay, so the first step, 2 things we have to think about. Sine is equal to a positive number. Okay, we talked about this earlier. People remember that diagram? All the trig functions are positive in quadrant 1. Just sine in quadrant 2, tangent in quadrant 3, just cosine in positive 4. So this is asking where sine equals a positive. What 2 quadrants would you expect to get sine equal to a positive in? 1 and 2. So that's where we're looking for answers. The calculator will give us one of them. Then that's our reference angle. From there, we can get the second one. All right. How do you get rid of sine? What would you do on each side of the equation here? Take the inverse sine. And take the inverse sine. And very simply, that's our first answer. It's the inverse sine yeah, thank you. Inverse sine of 0.6. So just type that in. That's your first answer. They didn't say whether to do it in degrees or radians. I'm in degrees, so I'll just do it in that. Inverse sine of 0.6. 36.87 degrees. Okay, now that's my reference angle. Now, does anybody remember what you do to get an answer in quadrant 2 with your reference angle? And maybe what I'll do is I'll write those in right below them. Yeah? That's quadrant 3. So reference plus 180. That's how you do quadrant 3.
90.
Nope. I like the idea of minus, but yeah. So it's 180 minus your reference angle. And I think some people remember this one as 180 plus your reference angle. Well, it's the same thing. Reference plus 180, 180 plus reference. Addition doesn't matter the order. And what about quadrant 4? Anyone remember the formula here?
270.
No, 360. Okay, so those are your formulas in each quadrant. I don't need the bottom 2 in this problem. Okay, just the top one. Okay. So my second answer should be in quadrant 2. In quadrant 2, you need 180 minus your reference angle. Okay, so let's write that down. 180 minus 36.87. That is the second answer, 143.13. Now, how often does that answer keep repeating itself? Think of the period for sine. How often does sine repeat? Every 2 pi if we did it in radians. What's 2 pi in degrees? 360. So you can add 360 to that answer as many times as you want. Oh, and the other one as well. I should write that on. Okay, so numbers like this are answers. I'm just adding 360 and over. I could subtract 360 over and over. Those are all answers from that bottom one. And from the top one, you get answers like this. None of those numbers that I'm doing now are the same as ones I had before, though. Okay, and the way John said it with 2 pi, that's perfectly fine if you do it in radians. Okay, you put 2 pi in. All right, let's try one more. And this is kind of a question that Luke asked about, but I'm going to avoid the problem he mentioned right off the bat. What makes this one a little harder? It's cotangent. Why is cotangent a little harder? Well, how about just in terms of pressing buttons on a calculator? What's more difficult about cotangent? There's no button for cotangent. So right away, I'm going to get rid of that. I don't want to deal with cotangent. But Luke said cotangent is the reciprocal of what function? And what does reciprocal mean? Flip. So if you flip what's on the right, or sorry, we'll start with the left. If you flip cotangent, if you take the reciprocal of it, you get tangent. And now let's flip what's on the right. That's the exact same problem to solve. The only thing I did is I flipped what's on the left, I took the reciprocal, and I flipped what was on the right. Now I've got a trig function I got a button for. Okay? If I don't do that, I'm not going to have a button. So any questions on what I did here? Flipped what's on the left, think of it this way, and I flipped what was on the right. Okay. Now to get x by itself, who can tell me what function cancels out tangent? What is it? Inverse tangent. Inverse tangent is perfect to use because you have a button for it on the calculator. So our first answer is this. Type that in, and that's the first one. All right, so let's see what we get. And I'm going to do it in degrees again. Second, inverse tangent of 1 divided by 2.5. 21.80 degrees. Now the tricky part a little bit, does anybody remember how often tangent repeats? It's not 360. It's faster. How much? It is. It repeats every 180. Okay, if you forget about it, we had these formulas. T equals pi over b and t equals 2 pi over b. I think it was in section 6.3. There's your first answer. Now, the original problem was looking for where tangent equals a positive number. Okay. Does everyone agree 1 divided by 2.5 is positive? Okay. 21.8. Actually, you know what? Let's write it down here. I've got that answer. Where else is tangent positive? Third. So I'm looking for a third quadrant answer. Here's my reference angle. What do you do to get an answer in the third quadrant? You add 180 to your reference angle. You just have to memorize that. So add 180, and we get 201.8. If you're ever not sure if you did it right, just take the tangent of that number, 201.8, and see if you get back what you started with. 0.39, that's basically 0.4. 1 divided by 2.5 is what I started with. So it worked. Okay, I just checked it. Then I could check 21.8. I didn't check it. But I also get 0.4. Okay, so I just showed you that both of these are correct because they give me back what I started with if I take the tangent. Hey, and let's see. How often is that answer going to repeat? Yeah, it's going to repeat every 180. And does anybody notice anything about those two answers? Well, let's let n be 1 in this first one. What's 180 times 1? 180. What's 180 plus 21.8? And where else do you see the number 201.8? The second answer. Technically, this time, these are repeats. If you write them both, I wouldn't mark it wrong. But by writing this and writing this, you're being redundant. They're the same answer. Okay? Again, you could write them both, and I wouldn't mark it wrong. That's fine. But you don't need to. Okay, so this section can be a little tough because there's not a lot of new things in it, but there's a lot of things that come together, like Pythagorean Theorem, unit circle trig, this ASTC diagram, along with the reference angle formulas, drawing a picture of what sine and cosine look like. So there's a lot of old things that come back and kind of combine together in this section. Okay. Is there any questions on that? All right, so I think that's a good place to stop. Homework tonight, not too many questions. Just these questions on 394. And then tomorrow we'll do a little bit with the graphing calculator tomorrow. Not a ton, but a little bit. And then on Wednesday, we'll work a little bit with trig identities. Okay? And we'll probably spend about a week on trig identities, so we'll just kind of scratch the surface on Wednesday.